Hello and welcome. Today we're going to explore Apache Spark, a powerful tool used for working with massive amounts of data. By the end of the session, you will understand how Spark works and why it's useful, learn how it compares to traditional big data tools like Hadoop's MapReduce, see how Spark makes use of distributed computing, run basic Spark commands in Python. So let's begin by breaking down what Apache Spark actually is and why it's such a game changer. When dealing with large data sets, one of the biggest challenges is speed. Traditional systems store data on disk and process it slowly, step by step. Apache Spark, however, works in memory, meaning it keeps data in RAM instead of constantly reading and writing to disk. This speeds up data processing dramatically, sometimes by hundreds of times. So some of the key features of Apache Spark include the fact that it's open source, it's free to use and backed by the Apache Software Foundation. In-memory processing, it keeps data in RAM for fast computations and instead of constantly writing to disk. Its scalability, it handles small data sets on a single machine or processes petabytes of data across hundreds of servers. It's multi-language support, so it works with Python, Scala, Java, and R. And its extensibility, it offers built-in tools for machine learning, streaming data, and SQL queries. So to fully understand Spark's power, let's compare it to an older big data framework, Hadoop's MapReduce. So before Spark, big data processing was dominated by a framework called Hadoop MapReduce. The problem? MapReduce stores intermediate results on disk, making it very slow, especially for tasks that require multiple steps. So what makes Spark faster? Well, Spark keeps most of its data in memory, avoiding unnecessary disk access, while MapReduce reads and writes data to disk repeatedly, creating a bottleneck. So for example, imagine you're cooking multiple dishes. If you store each ingredient back in the fridge every time you need to use it, cooking will take forever. Spark is like keeping everything on the counter. It's much faster. So how does Spark process data? Now that we know why Spark is fast, let's talk about how it handles huge amounts of data. It uses a technique called distributed computing. Instead of processing data on a single machine, Spark splits the work across multiple machines called nodes. Think of it like a group project. Instead of one person doing all the work, the tasks are divided among multiple people, making the job faster. So some key concepts relating to this are a cluster, a group of connected computers working together, a node, a single computer in the cluster, a driver program, the boss that tells nodes what to do, and executors, or the workers that actually process the data. Since Spark is designed to work across multiple nodes, it needs a way to manage memory efficiently. That's where RDDs come in. So what are RDDs? In Spark, data is stored in special structures called resilient distributed datasets, RDDs. These are collections of data that are distributed across multiple machines, immutable, they can't be changed after creation, and are fault tolerant, meaning they can recover if something goes wrong. So how are RDDs created? There are three main ways to create an RDD. From an existing collection in memory, by loading a file from storage, and by transforming an existing RDD. So let's create an RDD from an existing collection. Okay, first I'm going to check my Spark cluster is up and running here in my Docker setup. Since Spark provides APIs for multiple languages, we'll be using PySpark, which is Spark's Python API. So now that I've logged into Spark Shell, I'm going to launch Python inside our Spark master container. And now I'm going to import the necessary modules and start a Spark session. So what we're doing here is we're going to create an RDD by parallelizing a Python list. This means Spark will take a simple list and distribute its elements across multiple nodes in the cluster. So Next, I'm going to create an RDD from a list. So I'm going to now define my RDD variable using the parallelize method, which converts a Python list into an RDD, distributing data across multiple nodes. Great. Now I'm going to use the collect method when I print, which will retrieve the results from all worker nodes and returns them to the driver. Great. Now, instead of manually defining a list, let's load an RDD from a text file stored in our Docker container. This is useful when working with larger data sets. So the spark.read.text file loads the file into a data frame, and RDD converts the data frame into an RDD. And now I'm just going to fetch the first 5 rows of data. Great. Now let's show you transforming an RDD. Our text file is formatted as a CSV, a common separated values. Right now, Spark treats each row as a single string. We need to split each row into multiple fields so that we can work with structured data. So what we're doing here, this splits each row into a list of values. And so we can access each field separately. Great. Now let's apply a transformation on the RDD. Let's extract the first column as an integer, multiply it by 2, and keep the rest of the fields unchanged. So now we're going to double the ID column. We're going to keep the name as a string and convert the age to an integer. And now we're going to see a transformed RDD. Wonderful. Great. So while RDDs provide flexibility, Spark DataFrames make it easier to work with structured data. So let's load our dataset from a customer's CSV file into a Spark data frame. So I'm just going to run this in Python. This will read the structured data into a Spark data frame, and it will automatically detect column types from the CSV file I'm defining here. Perfect. Those are my first 5 rows. I can also display the column names and data types. I'm going to filter customers that are older than 30 now. again. Perfect, there we are. Pretty cool. Okay, so let's see what running SQL queries in Spark is like. Spark allows us to run SQL queries on DataFrames. So first we create a temporary view. This command registers the data frame as a SQL table. And now I'm going to query the data frame using regular SQL syntax. That's pretty cool. Okay, so we successfully ran Apache Spark in a Docker environment, created RDDs and data frames, and executed SQL queries. Now you're ready to process big data using Spark. Right, I hope you enjoyed that as much as I did. That brings us to the end of this webinar. We've covered a lot today. If you followed along, congratulations. You've just taken a huge step towards mastering Apache Spark, but learning doesn't stop here. The best way to get better at Spark is by experimenting, try running different transformations, working with larger data sets, and exploring more advanced Spark features like machine learning and streaming. And that's it. So see you next time.